Okay, let's talk about logarithms. Logarithms are used to figure out exponents, and this is what you have written on the top of your paper. But before we get into this, I know it looks kind of crazy, but before we get into it, let's just go ahead and establish a couple things about what the purpose of logarithms is. For example, if somebody walked up to you on the street and they said, 2 to what power is going to give me 64? Now, if you don't know off the top of your head, then you can use a logarithm to figure it out. And it's incredibly practical. Logarithms are used in measuring all kinds of things. A lot of things are based on an exponential or logarithmic scale, dealing with exponents. Logarithms help us find exponents. The decibels, meaning how loud something is, that's based on this scale. The Richter scale, based on this, measuring earthquakes. So this is used quite a bit. So, let's get started. The first thing you need to do, and this is just purely procedural knowledge, knowing where to put what number. The first thing you need to do is, well, know where to put what number. Don't panic, it's going to look a little crazy at first, but it's not that bad. This is an exponential form because you have an exponent. Every one of these up at the top is an exponential form because of an exponent. All of the ones down here, the next section on your paper, are in logarithmic form because they have a log. Don't panic, it's not that bad. I'm going to write out the first couple, and then we'll start realizing where the numbers go. There's not too much math to know at this point. It's just a matter of where the numbers go. This one is going to be log with the little 2 down here, it's called the base, of 8, and that is equal to 3. It's just a matter of rearranging the numbers. Okay? That number is called the base, and that one is the base as well. Notice that the answer, what it equals, is the exponent. Next problem. There will be another one of those in about 5 minutes. So the next problem is going to be log base 5 of 25, and that is equal to 2. But before I write the 2, let me clarify. What this really means is 5 to what power will give me 25? Well, 5 times itself, so 5 times itself, so 2 5s, an exponent of 2 would give me that. Okay, let's keep going. Log base 4 of 4 equals 1. Log base 7 of 1 equals 0. At this point, you probably have the hang of it already. So if you want to pause the video, try the next 2 or 3 on your own, that would be fine. The next 2, however, are written backwards. Although these are in exponential form, they're a little backwards from this. And again, the point of this is knowing what order the numbers go in. So before we even do anything with it, it might help us to understand it a little better if we wrote it this way. And while we're at it, if we look ahead, we realize that the exponent part of it is on the right. And to be consistent with what we've done so far, it should be on the left. There we go. That one actually is correct. Okay, so let's go back to here. This one, written as a logarithm, is log base 7 of, oh, come on, you didn't answer, 343. And that's equal to the exponent, which is 3. Again, this means 7 to what power is 343? Well, it's 3. Okay, log base 8 of 1/2. I'm going to put parentheses around that just to kind of keep it straight. Log base 8 of 1/2 equals the exponent, which is negative 1/3. Log base 10. And if it's a base 10, you don't have to write it. It's an understood 10. So if you put a 10 here, it is correct. If you leave it off, it's also correct. So when you use a logarithm on your calculator, it's going to go with a base of 10. So log, understood 10, of 1,000 equals 3. In a situation like this, let me tell you kind of like a 4th, 5th grade shortcut. There are 3 zeros on that 1,000, so the answer is 3. 10 to the 3rd is equal to 1,000. Okay, on the bottom, all we need to do... The bottom, all we need to do... I just got interrupted. I'm not sure if you heard that or not, but I just got interrupted. They think I'm not here, but I am. I'm not going to correct them. I got a video to make. Okay, on the bottom, we're just going to go backwards. So they started with a logarithm, and we're going to go to an exponent. So going from a logarithm to an exponent is basically going to be switching it from here to here. Now, there's a way that I do this and explain it that helps some people. I'm going to go ahead and write the first one, and then I'll kind of tell you my method. 2 to the 6th equals 64. I don't know if you can hear that on the video, but there's some noisy people out in the hall. It's a class change right now. Crazy people. Okay, here's the method that I use. I like to draw a heart on it. If we start here at the base, the order in which you point to them is the order in which you'll write them. So if you're a little confused about where the numbers go, 2 to the 6th power equals 64. You draw a little heart. That is a really jacked up, messed up looking heart, but it's a heart. So 2 to the 6th power equals 64. In this situation, we'll do the same thing. X, go here, draw the heart on the paper. And so the answer is actually x to the 0 equals 1. Okay. When we get to the next one, we start down here. I wonder what number I'm pointing to. It's an understood 10. So 10 to the 2nd equals 100. I'll just put it in red. 10 to the 2nd equals 100. And I think at this point it's pretty self-explanatory. I believe you know what you're doing, so I, again, suggest that you pause it, do the next 3, and then just make sure you're right. I'm not going to really explain much on the next 3, I'm just going to write them. That's not your bell. Stay in your seat. Now maybe the hall will be quiet and all those crazy people won't be running around opening my door thinking I'm not here. I'm hiding. Okay, there we go. All right, here we go. That is it for the top part, but I want to point out a couple things that are going to help us with the next section. Things that you may have been told but might have forgotten. So let's start here. Anything to the 0 power is 1. And I lied because actually, I'm going to digress for a minute. This has nothing to do with logarithms. Not really. Not with what we're discussing. I say anything to the 0 power is 1, but no one knows what 0 to the 0 power is. We can't quite figure that out. It's kind of crazy. So when I say anything, I mean anything but 0. But anything to the 0 power, with the exception of 0 itself, is 1, which you can kind of see up here. 7 to the 0 is 1. X to the 0, assuming x is not 0 itself. X to the 0 is 1. Things like that. Let me point out another thing. 25 to the 1/2 is equal to 5, and that's kind of crazy. We don't think of exponents as being fractions, but in this case it is. So if we say 25 to the 1/2 is equal to 5, well, how do we turn a 25 into a 5? Okay, your first answer might be, well, how do we turn a 25 into a 5? We divide it by 5. That's nice, but let's really treat it the way it should be treated. It's really a square root. If you have an exponent of 1/2, it's the same thing as a square root. I just wanted to point that out because that might come in handy later on. So for example, if I said you have 49, it's to the 1/2 power. Well, 49 to the 1/2 power is the square root of 49, and that's going to give you 7. Similarly, if I gave you 1,000 to the 1/3 power, that's not a square root, that is a cube root. So we're going to take the cube root of 1,000. Cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. Okay, and that's going to do it for the top section. There's another video that's going to explain the next one. We're going to go through several of those, and then I'll show you how to do this on the calculator.